Hello.
Good
Good
day.
afternoon. Hello. I am stepping in for Miss Kim just for a few. I'm holding it down as she's making her way to the live. I am Shailene. I have attended several of this amazing podcasts that focus on STEM education, STEM books, and resources. Yes, I'm a trainer at Destination Imagination. So I would like to extend my greetings as well to listeners out there that have been tuning in week after week. So, welcome to the podcast, the show where science, technology, engineering, and mathematics collide with the fascinating world of food. I can see that's what the banner we have on here says food from eat to energy. Um, so I would like to now welcome Mr. Douglas to take it on from here. I would like to believe that we're going to be embarking on a culinary journey that goes beyond the kitchen. Thank you. Thank you for listening. Thank you for having me. Mr. Douglas, please take it on from here.
Thank you, Charlene. Really appreciate everyone's time. Hope you're excited about this feast for knowledge that we're going to talk about today.
Yes.
That we're going to talk about how science is involved in how we breathe, air, drink water, eat food, and turn it into our energy. I'm going to turn off my camera just so I can save on the bandwidth. But I love this subject, and what we're going to get into, it's a subject that all teachers, students, and parents, and everyone just interested in science can relate to the science of something that we do multiple times a day. And so, without any other fanfare, let's just go over a couple of details for those who may be joining us to begin with. Next chart, please. This is the Stem-Zen program. This is number 6 podcast. Thank you for joining us. And so we're talking about the basic science. We want to keep it easy and fun and exciting. And today we're going to be talking about, so let's skip ahead a couple of charts, please. We mentioned that there's 10 topics in this Stem-Zen program. And today we're talking about food. Are you able to fast forward to a couple pages, or I'll just go ahead and you can catch up when you can, please? A couple more pages. We're going to talk about 6 food podcasts. Perfect. So give me just 1 second. We've got a windy day here in Seattle, windy and cool and rainy. So you may hear some of the wind blowing a bit in the background. But the main point is we're going to start with the book Air, Water, and Food, How We Breathe, Drink, and Eat with Science. And then we're going to talk about the advanced topic of good food goes bad. It's about what we can do in our daily preparations of our food to keep food from spoiling. Then there's the fun books called Plants Give, and also No Plants, No Food. We'll touch on those best we can in this conversation, and we'll see how deep we can get into it. But let's just get right into it. Next chart, please. The agenda is like the other podcasts. There you go, perfect. On the agenda, we're going to talk about the goals. We want teachers ready to be able to present this topic. We want students to understand and to ask any questions they can, and teachers and parents to be involved as well. We cover kind of a roadmap and overview. We talk about a one-pager. We get right into the concepts. And then we'll talk about videos that are available, some of the activities that we do, and that how teachers can also follow up with the students to make sure that learning is being engaged. Miss Sally, do we need to give you a minute, please? I'll go ahead and continue. Please cut in at any time. We're coming, go back a page, please, we're talking about sun, food, and energy. If you can go back one page. So as we talk about the food that we eat, we want to acknowledge and appreciate the science involved in the sun that shines and the plants that turn that sunshine into our food and the animals that eat those plants and how it all becomes our energy. So we're going from sun to food and energy. We'll keep those three topics in mind. Next chart, please. Some of the students may not like to call it the word photosynthesis, that's too big of a word, but it's basically sunshine into food. How we make the sunshine, captured in leaves, turn it into food, and then fruits and vegetables that get eaten by animals and get all of those that get eaten by us. And so we'll keep photosynthesis in mind as we talk. Next page, please. We'd like to acknowledge Mr. Ramon from the Philippines and his family members who helped with the book called Air, Water, and Food. So this is the one-page summary. We're going to go over the whole topic and then we'll dive into the details of it. But we have air that we breathe, water we drink, food in all of its many colors and shapes and flavors and spices that we eat, and we take all that in and how the food gets turned into bits joined with bits of oxygen that our lungs take in, and all that goes to each of our cells, trillions of cells, and gets turned into burned, quote unquote, air quotes, if you will, burned into the energy that we use. So this is the book, Air, Water, and Food. If you don't have a copy of the ebook and the video, please reach out to Ms. Sally and her team and get you a copy of that you can follow up with. Let's get right into the next page, please. I'm going to keep this conversation high level. If it's too fast and you have more questions that you'd like to ask, please go back and look at the ebooks and the videos. And Miss Sally, if there's any questions, please just cut in at any time. But it's fun to realize to stand up in front of the students and to take some deep breaths and then ask about what are we doing? And then we talk about what is air? And air is 1/5, 20% oxygen. So we take in 4/5 nitrogen, which we don't use directly from breathing, but that 1/5 is oxygen. And when we breathe in, we're taking oxygen into our bloods, and we'll talk about why we need it in just a minute. We also need to drink. And so water is the medium that everything gets dissolved in and helps us digest our food, right, in our stomachs. Then how the food bits with the oxygen go into our bloodstreams and get pumped through the water with the watery bloodstream all the way through our bodies. And how amazing it is that all trillions of our cells are connected and each get nourishment like fast food being brought on a platter to our cells. And so in the cells, the food bits that have carbon get combined with the oxygen and get burned. And we'll talk a little bit more about that. There's an acronym ATP, and we'll understand what's so important about that coming up. We'll talk more about that. But after we burn that, then that's the heart continues to pump. There's some carbon dioxide that is a waste product from the energy, and that gets put back into the bloodstream, taken back to the lungs, and exhaled. So that's why we breathe in and breathe out. So that's a quick overview. Don't worry if you didn't catch it all. We're going to talk more of these topics. Let's go to the next topic, please. We take a moment and take a pause point about oxygen. You can see most of the air that we breathe isn't oxygen, it's nitrogen. but the oxygen is what we need, and that's what goes from our lungs into our bloodstreams to our cells to get burned with the food bits to give us our energy. And it's amazing as students take a pause and teachers are excited about this, that how amazing it is that we have the oxygen in our atmosphere so we can breathe that, and that's how we live. We can also take a pause moment and appreciate that plants do the reverse. They take in carbon dioxide with the sunshine, turn it into food. The carbon bits gets turned into carbohydrates, for example, carbon, right? And then we eat that food, but then the plants give off oxygen. We do the reverse. We take in oxygen and give out CO2. Let's keep going following this thread, please. So as we breathe in, and you can see from the pictures there, we take in oxygen and molecules of O2. You can think of them as atoms if that's easier for you. Actually get added to our bloodstream. And it's an interesting pause point that we can see iron, the element iron around us, and we can see how iron rusts into the reddish rust, but that's the same element, iron, that's in our blood that grabs onto the oxygen, and rust is what makes our blood red. Next chart, please. We take a moment and we appreciate water, right? We talk about how much water there is on this planet and how very little, 2% of it, is actually water that we can drink, and the importance of water to help be what pushes around all of the food bits and the oxygen. Was there a question or a comment, please?
Hey, Doug, and everybody. No, I think not yet, but I'll keep checking with our speakers. Thank you.
No worries. We'll keep pressing through this. And like I said, it's a complex subject that we make very simple. We're focused on air, water, and food. So next chart, please. We get thirsty so that we make sure we drink. And for those of us who have ever lived in a desert, like I had an opportunity to live in Arizona, right, you can appreciate when you get thirsty and when a desert is so thirsty and the challenges that I live in Seattle now, and especially not in the summertime, but we get a lot of water, and we'll be getting a lot of water, a lot of rain this weekend. Next chart, please. We get an opportunity to explain to ourselves and, of course, excitedly explain to our students, why do we eat food? We eat food to get energy. The whole purpose of this topic today is to go from what we eat into energy. And so this is November here in the USA, and it's Thanksgiving, which is a big meal that we get to eat coming up here in less than 2 weeks. And you can see that. Okay, next. In addition to the food, we get to talk about the types of food, right? We talked about how plants grab sunshine and turn into fruits and vegetables, how grains like rice and wheat grow, but then also we need milk and meat for the proteins. And in addition to that, it's something called nucleic acids, and this is maybe for the more advanced students, but we talk about how you need those 4 things: the carbohydrates, lipids, which are the fats, proteins, which are the meats, and then nucleic acids, which give us, those are things that actually make the DNA and the RNA that gets into the function of the cell for those students who are more advanced. So we talk about the groups of food, and bio just means life, molecules. So it's the bits in our food that keep us alive. These are the 4 types of biomolecules. If there's no questions, I'm just going to keep pressing on. So all this food that we eat, in addition to the oxygen bits that are already there, through our stomachs, churn up, and through an acid, tear down the food we eat into bits, but it's more complicated than that and more wonderful, if you will, in that each of the major types of food, carbohydrates, take a special chemical from a special organs to break down the carbohydrates. The fats take another chemical, and proteins take another chemical. So all these, even though it's in one stomach, all these different special chemicals called enzymes, which are a catalyst, which break down the specific type of biomolecule. So how amazing it is that we have in our chemical machines different chemicals to digest the different parts of food: carbohydrates, fats, and proteins. There's no questions. Let's press on here, please. So what do we do with all this? Well, the bloodstream pumps the oxygen bits and the food bits to each cell. Think about that. If we had trillions of pieces all interconnected, think of what that would take for a machine. Well, how astonishing it is that every bit of our bodies, every cell that we see, is connected to the food bits and the oxygen bits. But it all breaks down to very simple. The cell takes in the food bits and the oxygen bits, and just like fire, whether it's paper or wood, is the carbon in the fuel, like in our cars or our airplanes, is combining with the oxygen, and that process is fire. Well, obviously it doesn't burn like a flame, but it's the same basic chemistry at each cell in our bodies, that the food bits with carbon combine with the oxygen to give off energy. Then we give out from that, those who like the chemistry part, carbon dioxide, which we exhale, we breathe out, and water, and of course, energy. And we get back to what we call ATP. So those who are interested, watch this space. We'll talk about that in a minute. So air, water, and food combine to give us our energy. And then we can take a pause moment for those students who want more information and talk about every life form, right? From the single cells around us in bacteria to the multiple life forms like plants, trees included, right? Fruit and vegetable plants, and then animals, and how we all use these processes to get our energy. Next chart, please. We get to talk about systems and how the systems all come together, how work together to breathing in takes the lungs, right, in our respiratory system, to the digestion system. And we talked about all the different organs that it takes, putting out special chemicals so that we can digest our food, and how the food has to process, flow through the body, if you will, that out of the soupy contents that come out of the stomach go into the intestine. And in the intestine, there are little teeny hair-like alveoli that absorb the nutrients into the bloodstream. And then we follow the food bits and the oxygen to the cells and all the different systems, the circulatory system. So let's go next chart, please. So it's great to have the oxygen bits and the food bits all together, but it takes our circulatory, our heart, and the veins and the arteries, the tubes, if you will, that push the blood out to the cells. The red shows the oxygen, the blood with the oxygen and the food bits. The blue shows the veins that bring the, once the food bits and the oxygen are gone and the CO2, the carbon dioxide, is in the blood, it goes back to the lungs where we exhale the CO2. And then there's a lot of other systems that the more advanced teachers can get into, right? But how amazing that all this has to circulate. That's the circles, as the blood circles around to our cells to give the food bits and energy and the oxygen so that we can get energy. Next chart, please. So we can talk about food, and this is a wonderful time to introduce how people around the world eat different foods, right? And so we can talk about what's popular in the West. We can talk about what's popular in Africa. What are the favorites? What are the locals? But even though the dishes that we cook may look different, the basic food bits are all the same. The biomolecules, the carbohydrates, the fats, the vitamins that we get, right, the proteins and the amino acids. And so even though they look different and they taste different, the basic bits are all the same. With the fact that we're changing bits of food and oxygen, burning them at every cell to give us our little bits of energy. Next chart, please. We need to take a pause and say we want to make sure everyone knows that there are these videos available, air, water, and food. In addition to the plants give, no plants, no food, and the good food goes bad. Those videos are available through Ms. Sally and the Edu Store Africa. Okay, next chart, please. It's a wonderful opportunity to take a pause and help the students understand how science integrates what we eat and the energy that we have. We talk about the air at a cellular level getting captured. It's alveoli is the name for the cell bits in the lungs that capture the oxygen in and put out the CO2, the carbon dioxide. How in our intestines, food bits get entered in the villi. And then at a cellular level, and it is so amazing to think about this little micro fire that's in each cell with the food bits coming in with the oxygen and then actually combining together, giving off energy, and then the waste gas CO2 actually going back out. And how this is going on every breath we take, every time we're alive, every time we're thinking and running and reading, right? Every activity we're doing is powered by this process. And the students can take this and relate it to, well, I had this for breakfast and I just breathed this and I just drank this. And oh my gosh, this process is going on within each of us as we speak. Next chart, please. Those who are maybe more advanced, we can take an opportunity to talk about the book Good Food Goes Bad. And it's talking about, we all witness, once you pick a piece of fruit or a piece of vegetables, right? Everything from carrots to peas to rice to wheat. We can see that once you've picked it, especially fruits and vegetables, over time, that goes bad. And for the countries where milk is popular, milk has a sell-by date on it. It only lasts so long, and we keep items in the fridge. Why? Why do we keep items in the fridge? Why do we have spicy foods? What happens to bread when it gets mold? And so we look at food, but then also the chemical changes that happen to make it spoil. And we talk about the steps that we can do to keep food from going bad, to keep it from spoiling. We talk about how we clean it, right? How we keep it cool, how we cook it. And then once the food is cooked, how we cover it or how we can it and preserve it just to keep good food from going bad. And so there's chemical processes with the science inside each one of us that turn the oxygen and the food bits into energy, but there's also other chemical processes that can make food go bad. And we talk about how bacteria and molds can break down the foods, how oxygen in the air for the food that's exposed. If you take an apple or other fruits, especially an apple, the ones that are acidic, and you cut the apple into pieces and you put the pieces open to the oxygen, you can watch the apple pieces go brown as the oxygen in the air joins with the chemicals in the cut apples, and you can watch that real time. So if you wash the apple, or other fruits, and then you eat it, it's perfect. But if you cut it and let it sit right in front of your eyes, you can watch the good food go bad. And it's some of the similar processes when we talk about all the things that we do to keep our food good. And there's also a video, Good Food Goes Bad. Next chart, please. To help the teacher prepare, we do have the materials in the teacher guide. When we talk about what's going on, we go through a word list, and then I love the processes, the one-page summaries about the boxes that go from the fresh food, the processes we do, like cleaning, keeping it cool or cold, cooking it, and covering it, and how we can bring all this together on why we're doing all this. And the students can see things. When we go to the store, why do we keep some foods cool and cold? Why are other foods covered in packages? Why are some things like cereals? Why are they in a box, right? Why are they sealed in a box? Well, we seal them in a box to keep out, and in packaging to keep out the oxygen, because the oxygen can break down the food components. But watching the food spoil right in front of our eyes is an example of the process that's going on inside of us that breaks down the food bits and gives us energy. And we talk about the things we do to prevent food from going bad, but it's also an example of what's going on. Next chart, please. For the students that need a little more, this is too advanced. We want to make sure we take, and we did this earlier as a process. Remember how cars were put together? We took an example of the processes, taking ingredients, the parts, and turning them into the final product. It's another chance for us to maybe I just like eating cookies, right? Maybe that's what I'm secretly doing here. But I want to make sure that we give the chance to talk about how the pieces come together to make the cookies and what we do with that. Let's take a pause and see if there's any questions, please.
Thank you, Doug. This is a very insightful conversation. When you think about food is something that we all consume, but do we understand the process?
Hey, Doug. This is Magaga. Hello, Miss Sally. Hello, Charlene. Hello, everyone. Well, can you hear me?
Yes,
Yes,
we
Mr.
can.
McGogger,
Okay.
thank you.
Oh, great, great. Well, today's podcast just took me back to class and just talks to me about how it feels to go over teach these topics in my classroom. It's interesting how you talk about the food, from what we eat to energy. And this reminds me right from the very, very first concept of ingestion, that is taking food, introducing food into the mouth. And alongside your explanation, I also it's striking the kind of interrelationship that both animals and plants do have, right? When you talk about the air and how important we get the air, how we get the air from the environment, and the role of plants in doing that, and also the role of that very, very air in oxidation of food that is giving us energy. So I'm staying tuned, and I'm just saying that I'm keeping on watching and listening as we go on. I just want you to know that I'm here. Thank you.
Mr. Magaga, we're so glad to have you here, and the others. We welcome your comments and questions. Thank you so much.
Great.
Ms. Sally, can we go to the next page, please?
Yes. Thank you.
In addition, and Mr. Magaga, your comments about the plants were perfectly timed. We take a pause moment and go and let's look at plants. What's going on? The big word's photosynthesis, for those who like the big words, but the concept is simple. Sun shines onto the leaves and plants make food. But it's an opportunity for the simpler topics, the easier students, to say, what do plants do? Well, plants make food that they can't eat. They make flowers that are pretty that they can't see. They give off nice smells that they can't smell, but people can. And so plants give all these. It's a chance for us to appreciate plants and the animals and us that eat them, but it's also an opportunity for us to say plants give and people can too. So there's a wonderful life lesson there as well. Let's go on to the next page, please. As promised, we want to talk, and this is more advanced, so not all students may want this subject, but every life form that we're aware of in the world around us, from the simplest one-cell bacteria to blue whales as massive as they are, or elephants, every life form that around us uses this simple process. And sometimes the chemistry and the terms we use can get lost, but this is a very simple process. There's a molecule called ATP, and the T stands for tri, which means 3 phosphor atoms. And that chemical, when we eat, we take the food, and just like if you took all the gas in a gas tank and you lit it on fire, it would explode, right? We don't want explosions. We want a little teeny spray of gas going into a cylinder that we can turn into car energy. Bodies are the same way. When we digest food, we don't burn it all off immediately. We use that energy to make one simple chemical where we go from a 2 phosphor molecule, to 3. When it goes to the 3, it saves the energy. When that other molecule breaks off and becomes the 2, it gives off energy. That is the process of all life forms. But if that isn't astonishing, amazing enough, the machine, the micro machine in our cells, and I don't know how they know this, but it's a fascinating fact, that little molecule that does this process, that takes the 2 and turns into the 3 to save the energy, uses a molecule machine that spins faster than a jet engine. That's astonishing. That's going on in every cell in our bodies. That's so amazing, this little process that it takes for us to live, to grow, to ourselves to repair, is going on inside of us. But simply said, without going too deep into the chemistry, it's one simple molecule that when we eat, we turn the molecule with 2 phosphate atoms into 3 to save the energy. When we need the energy, we break that atom off and it gives off energy. All life that we know does that. It's an astonishing concept. If I've confused you, you can go into more details in the teacher guide. But ATP is so astonishing to think that is all around us. So there's no more questions. Let's go to the next. Go ahead. A question or comment, please.
Great. Well, I think the way energy is being liberated in living organisms, rather in us, the bodies, ATP. I think in my cons, it's a chemical form of energy that is stored, and one of the reasons I think is because when the energy is liberated in full, it might burn the cell. So the body has its mechanism of storing excess energy. I think that is another way that I could put it. The way you're putting it, I understand it that way. That we could have ATP energy, that is a form of stored energy, so that the body can just use energy, but can also get energy once it needs some more. Just like you have something in stock, right?
Perfect explanation. Thank you, Mr. Magaga.
Right.
It's also an opportunity, and some teachers like to do this. Some teachers like to read about it because it can be a little extreme. But in a few instances, and we'd love to have more teachers do this, we ask for the teachers and the parents to coordinate. The students actually come to school hungry, so they haven't eaten breakfast. And like I said, some teachers like to talk about this, some teachers do it. We've only had a few try it. But when the students come hungry and they see breakfast before them, but before they can eat, we talk about what food came from plants and we take it away. And then what food came from animals that eat the plants, you take that away. Well, if you've done that, there's water and spices, the minerals like salt, on the table. There's nothing else. And then it's an opportunity to bring the food the students can eat. And we talk about why food matters, why air matters to us, why clean food, clean water matter to us while the students are eating breakfast. It's a lot of preparation on the teachers' and parents' part, bringing the food to the classroom. We've done it a couple different ways, but it's an opportunity for hungry and thirsty students to appreciate food and understand where it comes from. It's a good lesson. It's hard to do, but it's a fascinating experience for those who have done it. Next chart, please. We also get the opportunity to take the other topics that we've talked about, for example, cars and even airplanes, and how cars get fuel, people need food. And to make that comparison, that just like gas powers a car, the food powers us. And to draw that analogy, no, we don't drink gas, but we do eat food, and it follows a similar process. We compare and we contrast the cars and us. Any questions or comments?
Great. And what happens when we don't have food, when we are not eating, when we are starving? Could it be okay to explain that, why people grow thin is because our bodies are made of proteins, and proteins are only sources of energy when during starvation. So sometimes when you have no food, then the enzymes inside us get to break down the protein that is our bodies, and that is why we grow thin. Is that okay?
Perfect. I think that's a great example. And it's like once we've given the basics of the air, water, and food, we can add on to it. And the whole concept of enzymes and catalysts is fascinating, and how it takes different times, right? Just like plants take in carbon dioxide with the sunshine, but they need times to pause and to process it to make the food. We need time to process the food as well. Perfect example. Thank you. Let's talk about stories. Those of you who have been with these podcasts, we love to stop and just talk about stories, right? Because to me, telling a story brings science home. And there's a very interesting fact that the person that discovered circulation was just a few centuries ago, right? That for much of human history, we didn't know what happened. We didn't know, right? We knew that there was blood in our veins and there was a heart, but we didn't know that what was going on. Didn't even know it was a circle. A lot of people thought that blood just got consumed, right? And you just kept making more and more. Well, that makes no sense. But it took a guy named William Harvey to figure out the blood's actually circulating around us. And we can take the opportunity to talk about circulation, how astonishing it is for our blood to get pumped through our hearts out, connect to every cell, and then there's an interface, a capillary, if you will, where that cell then goes from being pushed out into the system that pulls it back to the heart, the red in this picture versus the blue. But how astonishing that connection, that cycle, that circle is. And then we can get on to other circles and cycles around us. Any questions or comments? It's also a great time to talk about worldwide how so many of the people live in places that have seasons, right? And our wonderful friends in Africa, you may have seasons that are less extreme. Those of us in the more temperate climates where summer is hot, but winter is cold, and in between is cool. And right now we're in the cool turning cold season here in the US, right? But you can see before your eyes the differences that the seasons have on our food cycle when you can grow it and when you have to store it. But in addition to the heat being encircled, just like being circulation where it pumps our blood, heat as it pumps around the earth changes how the impact on us. It's an opportunity with seasons, turn, tilt, and orbit. We'll leave that to you to look on your own. Let's go to the next page, please. So are there any other questions or comments before we turn to some other topics?
I can come in with a comment. Doug, can you hear me?
Yeah.
Yes.
I I I think the idea of seasons makes a great deal of sense because depending on the seasons, I think seasons also determines the kind of energy we use in our bodies or energy that we need in our bodies. Like when it's too cold, what happens in our body metabolism and what that means to the food that we eat. I think that really marries itself well with the. That's just a comment. Thank you.
Excellent example.
Excellent
Thank you.
example. Thank you.
Miss Sally, you have
Miss
comment?
Sally,
Thank you. Yes, and I can hear your echo. I also wanted to check if Frank has a comment to bring on board. Frank, are you there? And maybe as we wait for Frank, I think mine goes into the difference in how you bring about a topic. You're taking me back to this was standard 3, standard 4, which maybe I was 8, 9 years. But it sounded so complicated. Photosynthesis, nitrogen. And right now, the way you're explaining it, which brings about the power in breaking down any topic. It doesn't matter what you're teaching to children to a level that kids can be able to understand using examples and videos, the power of visualization. Right now, going through the photos we've seen, especially where you put food. Of course, you put food down, you make us hungry instantly. But then I think you make us want to know more because it is a beautiful image. And now we can relate even when you bring the science side of it to the everyday life. So thank you very much. And that goes to you and your awesome team that has put this
that has
together.
put this together.
Frank, are you with us
Can
now?
you Frank, are you with us now?
Can you get me? Hello?
Yes, Frank. Yes,
Yes,
you can
Frank.
go ahead.
Yes, you can go ahead.
Oh, thank you so much. Just had some, challenges here and there, internet challenges. I think that's why I joined late. But I think I followed some of the slides that were presented, and I had the slides, so I went through. And this is a wonderful topic. It's I loved this topic even back in school when we're doing biology. I think I've done that also at university level. Digestion is one of the best topic to just look at. It's fascinating, like the way it's being presented, knowing all these tiny processes that are happening at molecular level, the sources of energy and the like. And then I liked the comment on starvation when sorry I didn't get the name, but it's important to know. People have to know, or the students have to know how the body finds ways to compensate when you haven't eaten, you're in starvation, or you're fasting and the fasting has prolonged. So your body will try to compensate. So it will look for other sources of energy. So the primary source is carbohydrates, of course, but at some point when carbohydrates are not there, the body will start looking for fats, and then it will look for proteins, and that is why, it was concluded, people will get thin. I'll come in some other time for another comment. I wasn't there in the beginning. I wanted to see how it has begun. The comment on just stimulation of digestion at sight of food. Before you even take it, your stomach prepares for the food at that level. I wanted to hear how it was presented. But yeah, so this is a wonderful topic. Thank you so much.
Thank you, Mr. Frank. You can see on this chart that there are a lot of other topics. Once you have the basics of what we talked about, you can then add on to it, right? In class 1, we talked about fusion in the sunshine, which is the source of the sunshine, how that energy comes down to plants. We can talk about what do plants need? What do they, quote unquote, air quotes, eat, right? How the plants need to have the sunshine and the warmth and the water, right? And the soil, will they get the whole flow of the elements from the water and the soil into the plants, and how amazing that is that they make food. Are there comments? I'll keep going. Please cut in if there's any questions or comments. We also take a pause moment and say how astonishing it is that 4/5 of the air is nitrogen. When we breathe in the nitrogen, we do nothing with it. All we do is breathe in and breathe out nitrogen. But nitrogen as an atom is so important, but we can't use the nitrogen that we breathe in. Nitrogen has to go in the soil, be broken down and changed into nitrates by bacteria. Then it is absorbed as fertilizer into the plants to keep the plant alive. That without the nitrogen from the air being changed into a usable form, another chemical the plants can use, that we would have no plants, and then we wouldn't have no plants, no food. And so how the whole nature and the environments, and that's next week's topic, we'll talk about that in a bit, but how nitrogen is in a cycle that helps the plant grow. Then we talk about other cycles, how astonishing it is that the states of water, as in the sea where the sun shines on it, again, sunshine again, and then that water evaporates and then turns into the water cycle around the world. But also the carbon, the very basic atom in each of us and our food, how that has a cycle as well. And we can talk about the different cycles that go around us. In addition to these topics, we can take a pause, and if at least in the West, in the food that we buy at the store that comes packaged, on the package is a label. And in that label are things like calories, which show how much energy is packed into this food. And then in addition to the energy and calories, there's the carbohydrates, the fats, right? The proteins, and how that's actually on these labels, and students can see that. And then we need vitamins. Why do we need vitamins? And I can take that whole tangent and talk about how the different vitamins are used in this process as we go from the food that we eat to the energy we use. And all these cycles have to come together in an environment. And it's an opportunity to talk about how important it is to keep the environment clean, for the water that we drink, food, and the air that we breathe, and how we impact that by our many activities. And we can get into the environmental piece of it. Then you can bring it all the way back and going from a worldview back down to a personal view again and say, what's a taste bud? What's our taste sense? Why do we think people have tastes? Why is that important? Why do different foods have tastes? Why do we like the sweet and the sour and the savory, right? Why do we have tastes? And we can talk about how taste is an important part of this as well. So, are there any other comments and questions? Hearing none, I want to just take this opportunity to, those who've been involved in the other 5 classes that we had, right? Food brings so many of these examples from the other classes together, right? It is an opportunity for us to bring in the energy and how energy changes form, right? We talked that in class 1, and how the sunshine and the energy that we can feel when the sun shines upon us. And then we watch it as it shines on a leaf, and how the leaves are taking that in the cells of the leaf and grabbing that energy and using it to convert chemistry, and how that chemistry saves the energy of the sun. And then how we then eat those chemicals and change that back into energy. And how amazing, and that's happening all right in front of us. But then as we see cars and even computers, right, and airplanes, that they're taking energy and converting it into other forms, right? And how we burn fuels with the carbon during the oxygen that gets changed to electricity that powers our computers and our electronic devices, right? So all this is interrelated, and it's such a wonderful opportunity for us here to bring all these different processes together. We have a food web, right? We talked about Ubuntu last time about how we're all connected. Well, the food web shows this so graphically in front of us that as we look at the full flow of energy and food throughout our world and how it's all interconnected, right? We can go into those who want to dive into the ATP. To me, it's a fascinating subject. I think we've talked it enough here, right? And Mr. Magaga brought up about the seasons as well, and how you can not just show how heat flows around the world, but it has an impact on the people that live in those different places in the different seasons, and how astonishing it is that in America, when it's wintertime, in Australia, it's summertime. And those of you in Botswana as well, right? And how you can explain that and use that, and the perspective we're able to give students from being personal to the food that we eat to being global and being interconnected. Ms. Sally, are there any other comments? I know we're going to be wrapping this up in about 8 minutes. Any other questions or comments, please?
I truly have so many questions, but I don't want to delay you. It's just super fascinating, and it just feels like sometimes we rush the entire education system. When you think about how much sometimes we expect the learner to know within a very short time. Let me first give it to Frank, and it looks like we've lost Mr. Magaga, and Shailene and Calvin. Shailene, would you like to add anything on this? Or Calvin? Or Frank? Okay, maybe we can carry.
Maybe we
Thank
can
you.
carry.
Thank you so much, Sally. Yeah, just agreeing with what you just said, that the education systems we have in Africa sometimes are not really structured in a proper manner to advantage the learner gain as much information as they're supposed to learn. So because things are compacted and structured in such a way that we get to focus on sometimes not necessary stuff and leave out the most important thing. So this podcast is just showing that some of those things that we missed or we might miss as we are teaching our students. So we need to really revise and focus on these nitty gritties so that our students can learn.
Thank you. Great comment. I think it's important as we are nearing the end of this presentation that we take a pause and ask the students, the children, what do they think about food, right? That we're taking the opportunity to check what have they learned from this presentation. And of all the science that we talk about in these podcasts, air, water, and food is every minute, every second of every day, students can understand what's going on. And so at the end of this, we took some tangents that can get complicated, but back to the very basics: air, water, and food. And now we take those three ingredients and we let the students come back to us. And we talk about, what's your favorite food? Why is it your favorite? Is it because of its taste? Is it because of, the energy you get from it? Why is it your favorite? What's going on with that food? And have them relate back to us the process that we talked about. And one of the assignments we give the students at the end of this is to go home and to talk to their siblings and their parents and their relatives and explain to them what they learned, nice and simple: air, water, and food, how we get it in, what happens, right? We get our energy. And then to relate that, and then come back to class and explain to us how they explain it to others. And it's fun that the students then become the teachers and they relate back with energy how these three parts come together. Ms. Sally, do you want to open up for any last questions?
Yes, please. I see Mr. Magage is back. I'm sure you have some questions.
Not really for now.
just want to take this opportunity to thank everyone. This is a fascinating subject. It can be as simple or as broad as we want it. It's real life in process right in front of us.
Great. Yes, Doug. This one, I like how simple you've made it, because talking from the perspective of a high school teacher, I think this is everything that I teach when we talk about nutrition, and this is from grade 9. And what we do is that we start by introducing what it is, plant nutrition, then you go to animal nutrition. Plant nutrition, we talk about the photosynthesis, I just mentioned, how plants, and it's interesting also seeing how energy changes forms. Like, the plants are using the light energy and converting it into chemical energy, and that's also important to show to students. And I like the photos that you had that shows how that process, even if you avoid the big word photosynthesis, but now we're talking about sunshine and how that sunshine gets introduces energy to the system. And when we talk about the whole system of digestion and explaining why, just like machines need fuel to fly and everything, and human beings and organisms also need energy, and how do we liberate this energy? Like I said, from ingestion of food, breakdown, digestion, and then absorption when the food is now leaving the alimentary canal, or rather the digestive tract, into the bloodstream, then from the bloodstream to the assimilation process that gets to the cells, mitochondria, energy. That's all fascinating. And for me, it's just amazing how you broke it so simple. And I'm telling myself, these materials, I can use them and walk straight to that elementary school and have fun talking about energy, food, air, and water. So thank you. This has been really enjoyable and nice and relatable to my profession. Thank you so much for your time and all this that you have for us.
Thank you. We're so exciting that this will be used in the classroom. That's everything we're doing is for that reason, sir. Thank you so much.
All right.
One quick comment is just back on, we started this journey talking about sunshine, the light energy, food, the chemical energy, and then that we use as energy around us. And it's so fun to share this air, water, and food with students. That's so practical. That's something we can all relate to. And am I the only one? Did this make anybody else hungry?
No, you're not the only one.
Miss Sally will turn over.
Especially this particular picture, right?
Sandwich.
And looking so nice. So
nice.
Maybe, Doug, I could just emphasize on just again appreciating you all. Thank you so much, Frank. Thank you, Mr. Magaga, Mr. Malunga, Mr. Magaga, Calvin, Shailene, and to all our listeners who could be listening from different platforms. We very much appreciate your presence here. We appreciate your input. And please note that we have a lot of these resources that we'd love to share with you, so you can as well share within your communities. So we have these books in forms of ebooks. We can also do printed books, and we have videos. So please do comment on our platforms. We are on a fundraising mission to ensure that we can get in a position of distributing these books for free, and especially to marginalized communities across the continent. Yeah. So unless Frank, Magaga, or Doug, you have something to say, I would say this has been truly awesome. It's been a pleasure hosting you. And we look forward to seeing you again on Saturday.
Yeah, and big ups to your co-host, Charlene. She did an amazing job.
At the beginning.
Thank you, Charlene.
Thank you, Shailene.
Thank you.
Yeah, it's getting very hectic as we get close to the festive season. There are just so many events. I was running from a huge event, please allow me to brag. We've just broken the record of having the first children's parliament in the world.
Oh, sorry.
Sorry.
Well done. Well done.
Thank you. So I'll send you the video clips. We had children from villages across Botswana that came, they did their children's parliament. We had State of Nation address last week. And of course, they didn't just address the issues they feel, they literally addressed their pressure points and small bits of like corporal punishment. Do we agree we should be beaten in school?
No, it shouldn't be.
Parents are not parenting us. We're being raised by gadgets. Is that right? Should we continue like that? They had serious issues. We were all crawling under the carpet because they were literally talking to us. We were face
Compliments.
palming.
Very impressive.
It was so impressive. I'm so proud of the children we have. And they're on a trip where they're going to visit various presidents in different parts of Africa. It's a huge project and we're with them. And of course, we had a session to read to them and tell them about our Stem-Zen books and give out some books as prizes. Yeah. And I can see Magaga Jr. on the screen. She would have loved to be in that parliament. I think, Miss Magaga Jr., you need to form an African parliament where you get children from across the continent. These children have left with a family stating they're going to have a virtual parliament every month where they address the plight of children in Africa. So, Miss Magaga, I should give out your name, right? I can see the smile. The smile is a yes. So thank you, everyone. We're 2 minutes past our time. It's been a pleasure, and we look forward to seeing you again on Saturday.
Next one's on nature.
Yeah. Enjoy your weekend. Bye. Cheers.